Hello guys, my name is Emanuela. My teammates are Carlos, Yarovit, and Kevin. We are going to present our project that is about DOE liquid boiling. Boiling water is known to eliminate organic contaminant and changes raw material into the pure state at the cost of time. Also, when adding a solute to a solvent, the boiling point becomes higher than that of the pure solvent. Therefore, our goal for this project is to show if using different pen material, burner size diameter, and adding salt to the water will impact the thermal conductivity by boiling water and the time it takes to reach the boiling point.
The factorial design was chosen to be 2 to the third with 2 replicates. The first factor is thermal conductivity with a low of 51 watts per meter kelvins and a high of 273 watts per meter kelvins. The second factor is the area of the burner with a low of 19.63 inches squared and a high of 50.27 inches squared. The third factor is the presence of salt with a low of 0 grams and a high of 5 grams. Fabrication procedures and measuring method. First, prepare water at room temperature by filling a 5-gallon bucket to about 2/3 full and leaving it out for an hour. Second, prepare carbon steel wok and aluminum pot on stovetop. Third, measure 3 cups of water and pour into each cookware. Optional. Measure 5 grams of salt and ensure it is fully dissolved in water for the third factor. 4. Place thermometer probe into the cookware with water and lid on. 5. Prepare stopwatch. 6. Turn the fire on high. 7. Once temperature reaches 100 degrees Celsius, stop timer and record results.
Here are the main factor effects. Here we have the 3 main factor effects: factor A, thermal conductivity; factor B, area of the burner; and factor C, presence of salt. We can see that factor B had the highest effect in boiling water, factor A had intermediate effects, and factor C had the smallest effect. Here we have 3 two-way interaction effect charts. Here we see the thermal conductivity and burner size have 2 parallel lines indicating that there are no interaction effects between the two, while as the thermal conductivity and presence of salt have some interaction effects, as well as the area burner and the presence of salt.
Our data analysis of variance was calculated through Excel and confirmed through Minitab. We first validated the degrees of freedom are correct, which is a total of 15, 1 degree for each factor and interaction, 8 degrees for the error, and this totals to 15 degrees of freedom. Following this, we looked at the p-values and concluded that almost all factors are statistically significant since their respective p-value is smaller than their alpha value of 0.05. The only interaction that is not statistically significant is the interaction between thermal conductivity and burner size, since it has a p-value of 0.2. Next, we considered the f-values. We were able to determine which factor was the most impactful by looking for the largest f-value. Through this, we found that the burner size was the most influential, followed by thermal conductivity, and then by salt presence. As for two-way interactions, burner size and salt presence leads as the most effective, followed by thermal conductivity and salt presence, and lastly by thermal conductivity and burner size. As the analysis of variance concluded that thermal conductivity and burner size were the most vital individual factors, we used them both to model our regression equation. As you can see on top of the slide, the equation is listed. Based on both the surface plot and contour plot, the optimal method to achieve the quickest boil time of roughly 235 seconds would be to use a large burner size with a pot that has low thermal conductivity. Unfortunately for the normality assumption, we reject that the data follows a normal distribution since the p-value is smaller than the alpha value of 0.05. Also, by analyzing the plot, it is clear that the data does not follow a straight line. In order to avoid this in the future, it is recommended to have more than 2 replicates so that the data can normalize.
The independent residual analysis. The plot on the left shows distinct grouping of the raw data, showing a 2 to the third factorial design. It also shows a clear separation between using the large burner versus the small burner. The average of the replicates are plotted on the right. The first 4 result number is with salt, and the next 4 result is without salt. The time it takes for salt water to boil to 100 degrees Celsius is generally higher than without salt.
For this slide, I'm going to talk about equivariance. So as we can see on the graph, we try to plot the residual versus the fitted value for us to better interpret the equivariance. So these points are about the same path regardless of the fitted value. Therefore, the points are similarly spread out enough for us to conclude that we have an equivariance. Overall, due to the result from the experiment and the data analysis, we noticed that the thermal conductivity and the burner size diameter significantly affect the total time it takes the water to reach 100 degrees Celsius. Yet, the presence of salt has a negligible impact on the time it takes the water to reach the boiling point. Thank you for listening.